Well,
So,
it's nice to have a
fluidics.
hardware video and a software video.
Okay, you bet.
Okay, so that was the hardware, all right.
Yep.
So the next thing is I went to set up and focus.
Well, let's close the pump control
Okay. All right, so,
and the setup and focus screen as well,
okay.
and then go to context.
Context. So that's the part that I didn't do. All right, so stop and think about that. Once we do all the hardware setup and we change the filter, syringe, and everything, we're done with the hardware setup. So now we need to go to the context.
Mm-hmm.
I remember that. All right, the first one that we did was capture. So now we have to think about this. Distance to the nearest neighbor. We basically set this up before,
That's fine.
but that looks like a different one than we set up. So
It is a different one.
Right.
Is that a default?
It might have been the
Yeah.
default for this instrument
Right.
because it's been through multiple
Sure.
applications.
Okay.
And so
Right. So what we're looking
that's
at.
why I teach you application specific.
Makes
So what
sense,
we're
yeah.
looking at here is what do we believe is the distance to the nearest neighbor object in microns? So we're looking at our 5-micron algae, and we're looking for possible invasives. We want to see something, give it some room, so I would say 5 microns.
We could do 5. We could even do 2 on this one. We could make it a little bit lower because we know that the sample is extremely concentrated.
Okay, all right, so that's the reason. So 5 would be okay, but 2, because it's concentrated, it's going to be closer.
Would it also be reflective of the magnification that it's 10x instead of 4x too? Maybe?
No, because
No.
it's the same distance.
Yeah.
Even if it's,
Okay, okay.
It has to do with the density of the particles, how close they are together, because it's a high-density solution.
Okay,
culture.
okay.
All right, so that's done. Now, the other thing that we had before was a 20 and 20, dark pixels and light pixels. And that seemed to work okay. So if I was doing this again, I would do 20 and 20 again.
And the only time you would change that is if you're running a sample and you're seeing, wow, there's a lot of particles passing through, they're not being imaged. And you know that they're being imaged when you see that red bounding box
Okay.
created by
Yes.
the software.
Right.
Gotcha, okay.
So I would go here and do 20 here. All right, now the question is, this one has a selection for dark pixels.
Mhm.
So what that tells me is we're looking for dark pixels.
Yes.
But I don't have to select light because we just want the combination to be 20 and 20.
Yep, that should be
Okay.
fine.
Right. So acceptable region, I think we leave all this alone.
That is the camera's field of view.
Okay.
So if perhaps you ended up with a particle that ends up getting stuck in the flow cell, you could change the acceptable region and make the right side only 1200 pixels wide instead of 1290 pixels
I
wide
see.
and eliminate the right side of the flow cell.
Okay. All right. Great.
But we want the whole thing, so.
Yeah. And then the images, I don't see a need to change anything here either.
Yep, so
Okay.
collage image border padding in pixels is 5.
Yeah.
That's a great image border to have, so that way you don't crop the particle on accident, particularly if they
Okay.
become more translucent toward the edges.
Great. Okay. Sorry. So I'm done with capture. The next one is flow cell. So the flow cell is the flow cell depth. So what we're looking for here, hang on a second. I don't see anything here where we need to change. It's down here. So the above,
So just to verify though, what we have selected is flow cell 100, and in here we have a 100 micron flow
that's,
cell.
yes,
Okay.
exactly.
Gotcha.
So that's critical to change this to the flow cell that you have in there. This one is not so critical. I think the last time we looked at it was 4,000, but 2,000 is fine. Down here now, we need to look at the tube length. So above the cell, we measured 11 centimeters above. And below this flow cell, we measured 16. And that's it. So that's done. And then we go to fluidics and the sample volume. we have 1 milliliter, and the flow rate is 0.15. And we're dealing with 10 times, so I don't have a feel yet for what the flow rate should be, but that seems to be somewhat subjective based on the magnification in the flow cell that you have.
Size, yeah.
Does the hardware configuration guide on the table have a flow rate that you
Good
might
question. Ah, it does. All right, so
Well,
let's
what do you
point
know?
that again. Right. So we look down here at 10 times. There's our flow cell.
Yeah.
We use the 1 milliliter syringe, and sure enough, the flow rate indicates 0.15 to 0.2. So 0.15 to flow to 0.15 is what it is. And if we wanted to, we could make that 0.175 or whatever, but that seems to be fine the way it is.
Now, do you see any red flags?
Oh,
I
do.
see. I
Literal
literal.
red
Yeah,
flag.
I know. I was going to ask about that. Yeah, so.
So what we have here is a slower flow rate and a very fast auto image rate, which means the efficiency here is almost 31%. And the efficiency
That's
range
too-
suggested at 10x is actually 20 to
I think
25%.
that's too high, yeah.
So you could either increase your flow rate or decrease your auto image rate. And it's subjective. So
It is.
I'll
All
let
right,
you
so
play.
all right, so it says the auto image rate for that is 20, so that's what we have. So even that's right, so we have to somehow address this. So what you're saying is we can change the flow rate or change this.
Mhm.
So let's see if I change this to 7.5. It didn't do it. It didn't get rid of it yet, so I'm going to change it to 0.2. It got rid of it. So now we're set. So the sample volume is 1 milliliter, flow rate is 2 milliliters per minute, and we'll leave the auto image rate at 20 frames per second. All right, so that gives me efficiency of 23%. Everything else, there's nothing else to do here, and there's nothing else to do here. Although, if we have a high concentration and we wanted to dilute it, we could dilute it, but I see a dilution ratio plugged in here, but this is not checked, so this is not going to be effective. Is that correct?
that's correct.
Okay, so we're done with fluidics, and then the next one is the filter, and that's the last one we have to deal with. So the diameter, let's see, what do we have here?
Can you read out the current minimums that are listed as acquisition filters?
The acquisition filter, that's here.
Yes.
The diameter minimum is 10 microns,
Mm-hmm.
and the diameter maximum is 1,000.
So basically, only data that is between 10 microns and 1,000 microns will be collected. And since we're trying to image a 5 micron particle, then
Right.
we need to reduce our
Below
diameter
5.
minimum. The alternative, too, is that you can just say no size filter if you don't want one at all.
Mm-hmm.
But if you do want to use a size filter, then the smallest practical filter to use is 2 microns because that's our minimum image size.
Right, and that's based on times 10, 2 down here somewhere. Right.
That's just based on the FlowCam in general,
Okay,
not
right.
not just that effect.
All right, so we can move this down to 2 because we're interested in capturing as much as we can. And then everything else is fine, and it's showing that it's using an ABD filter.
An area-based diameter filter.
Okay, right. So all of that's done. We don't need to use anything else. The advanced acquisition filter is not in play. And from what I remember is that's all we have to do are these 4. So we're done.
Okay.
So we're going to say okay, and then we're set up now.
Okay.
From what I remember at this point, that configures everything, and then we can now do the sample. Is
Okay.
that correct? That's the third section of it, which
Right.
is software.
The software.